Okay, let's take a look at our warm-up problems. Number 13. Where do I want to start on this one? What should I do first? Division, right? I've got division and multiplication here. They're equally important, so we do them in order from left to right. So we'll start with the division. 12 divided by 3 is 4. And then I've got times 12 plus 10. What should I do next? The multiplication, good. 4 times 12 would be 48. And then plus 10. So what do we get here? 58. Very good. Number 22. Where should I start for number 22? Inside parentheses, we've got two sets of parentheses here, so we'll work left to right. We'll start with this guy. And then inside my first set of parentheses, I've got more than one thing to do. What should I do first? Yeah, I've got addition and subtraction. They are equally important, so I'm going to go left to right. So 11 plus 42, what will that get me? 53. 53 minus 5, 48. So I've got 48 divided by, we've got to work in our other set of parentheses here. Just one thing to do. 11 minus 4 is 7. So 48 divided by 7. How many people typed this in a calculator and gave me a decimal? How many people wrote a decimal on their paper? Okay. What did you get if you wrote a decimal? 6.85. Okay. Rounded to 2 decimal places is good. Did anybody just leave this as 48 over 7? Because that would be okay too. I didn't tell you you had to round, so you can leave this as an improper fraction if you wanted to. As we work through Algebra 1, we'll talk about times when we want exact answers, and we'll talk about times when we want this approximation. Okay? So either was fine for today. For today, I want to talk about another kind of review topic. We're going to talk about solving linear equations. This is something that you have seen before, you've done before. We're going to take a look at, I would say, kind of the tougher end of those problems for today, but still stuff that's in your wheelhouse that you can handle, that you can do. And we're going to do a little review together to get us started to kind of just refresh. Here goes. Okay. So when I talk about solving, if I give you the directions to solve something, what are you trying to do? I'm trying to solve, yeah, right? What's your answer going to look like? I've done the whole problem, and at the end, I write something that looks like for our variables here, we've got a lot of x's. So if I'm trying to solve, what do you think I'm trying to solve for? X. So my final answer is going to look something like x equals something, right? So when we're solving, our goal is to get x by itself. And we're talking about solving all different kinds of equations this year. And then next year, when I see you in Algebra 2, we're going to solve all different kinds of equations in there as well. We're going to start with some linear functions for today. Linear functions, if I were to graph these, they're going to look like a line, and the slope may be positive, or it may be negative, or it may be super steep, or not so much. These are all linear equations. And our goal is going to be to get x by itself. Okay, anytime I'm solving, my goal is to get x by itself. Isolate the variable. Okay, get it by itself. X equals something. So we just worked on order of operations, right, and evaluating yesterday. Okay. For order of operations, remember PEMDAS? We start with parentheses and then we work our way down that list, okay, in order of importance. When we're solving, we're still going to think about order of operations, but it's going to be in the context of sort of unraveling to get things away from x. So we're going to be working through that list from the bottom up. Okay, we're going to be going in reverse order. I want to move the addition subtraction stuff first then the multiply divide. We won't see any exponents today. But then if I've got stuff trapped in some sort of grouping, then I would move that last. I can't tackle any of that until all the other stuff is gone. So let's take a look at A to start. Okay, I've got x divided by 3, or x over 3 minus 7 equals negative 2. I want to get x by itself. So we need to start with those sort of lowest priority operations first. We want to move those things first. So since I've got minus 7 here, that's a lower priority operation than division, right? For PEMDAS, division is more important than subtraction. So I want to get rid of the subtraction, undo the subtraction first. If I am subtracting 7, how can I undo that? By adding 7, yeah. So I want to add 7 so that it's gone from here. And whatever I do to one side, I do to the other as well. Sometimes you may hear this explained as sort of moving the 7 from one side to the other. I know I use that phrasing from time to time. The idea is I don't want to be subtracting 7. I want this gone. So in order to get rid of the 7 here, to cancel the 7 here, I have to do the opposite operation. Okay, so that's what I'm doing. So I'm left with x over 3 equals negative 2 plus 7 will give me 5. Now I'm left with x over 3, x divided by 3. How can I undo division? By multiplying, right? So where I've got x divided by 3, to undo that, I'm going to multiply both sides by 3. So I get x equals 5 times 3 is 15. Again, whatever I do on one side, I have to do to the other. Not too bad? Okay. And that problem had a fraction and everything. Okay. B, same idea, different operation, but same idea. So what's my first step for B? Subtract 3. I start with those lower priority operations. So I'm subtracting 3. It's gone from the left-hand side. And I've got 4x equals negative 17 minus 3. Negative 20. Very good. Okay. So 4x equals negative 20. What's my next step? Divide. Yeah, I've got 4 times x right now, so we'll divide. So I get x equals negative 5. I would like you guys to try C. Try C. What's our first step for C? Yeah, subtract 12. So I have 5x equals 75. All good? What do I do next? Divide by 5. I want to get x by itself. I've still got 5 in there. Since it's multiplication, we undo it with division. So I get x equals 15. Very good. Not too bad. Okay. Let's take a look at D. Okay. For D, this time I have more than one thing being divided by 3. So in A, x was divided by 3. That was it. Now I've got x plus 7 that's divided by 3. We saw a couple of problems yesterday where we talked about how if I've got this sort of like fraction setup, this division setup, and I've got more than one thing happening on top, I treat that like a group. I treat it like it's in parentheses, and I have to simplify that first. Same idea when I'm solving. If I'm dividing more than one thing here, I want to treat this like it's in parentheses. I want to treat it like a group. And so my first step on D is actually going to be to get rid of this 3. So I'm going to undo this division to start. Okay. So my first step here is going to be to multiply both sides by 3. Right? Since we're dividing by 3, we can undo that by dividing. So we get x plus 7 equals 6. And now I want x by itself. I'm adding 7, so I need to get rid of that. So I'm going to subtract 7. We get x equals 6 minus 7. -1. Very good. For E, I can see my group there. There are a couple different ways that we can handle the parentheses that we have here. For some of our later problems, we're going to talk about distributing. But since I only have x in this one place, I'm going to handle this one by getting rid of the 6. I've got -6 times x minus 1 in that group. Okay? So I'm going to go ahead and divide away that -6. I'm going to get it out of there. Again, we'll talk about a different way that we can approach that a little bit later. But I'm going to choose to get rid of that -6 right out of the gate. So I have x minus 1 left, and then 18 divided by -6 would give me -3. Last step here, add 1 to both sides. So we get x equals, this is a tricky one, -3 plus 1, -2. Ethan, you said you did this a different way. What did you do?
-6 plus 6 is 18 and then subtract 6 from 18, I got 12. Okay. I had -6x. So I had to divide -6x by 6. And -6 divided by 12.
Okay. So I'm going to catch up to where you are. I can't write quite as fast as you were explaining it to me. So you said you distributed right out of the gate. That's okay. And then you said, well, I've got this 6 here. I need to subtract that to the other side. And then you ended up with 12, yeah? And then you had to divide by -6. Did you still get -2? Perfect. That works too. For some of the problems that we're going to take a look at in just a few minutes, we're going to distribute as our first step as well. Yep, that's okay. I want you guys now to try F. Try F.
Would it be -2 or +2?
You want to move this guy? So since he's adding, it would be -2 to get him on there. No, he's got an X. First step on F. What do we want to do first? Subtract 2. So we have 8x equals, what do we get here? This is a tricky one. Close, -4, right? -2 and -2, -4. What do I do next? Divide by 8. We want to get x by itself. So we get x equals, yes, and make one adjustment to that for me. -1/2, yeah. Not -2. If you got -2, you flipped your division, okay? 8 divided by -4 is -2, but that's not what we have here. We have -4 divided by 8. That would be -1/2. Very good. We're going to look at one more on this front page. Pop down to G for me. Okay. Nobody got upset when I gave you a fraction in that very first problem, so we're going to do another one of the fraction ones, okay? Because we're cool with fractions. So I've got 3/4 x minus 5 equals 4. What's my first step here? Yeah, it doesn't even matter that there's a fraction right now. That's not my first priority. My first priority is to move that 5 to the other side. So we want to add 5 to both sides. So I have 3/4 x equals 9. Now I got to deal with that 3/4. Okay. There's a couple, just like E, where you could divide the 6 or you could distribute the 6 at the beginning. There are a couple different ways that we could approach this 3/4. Okay. One way that I could approach this that sometimes makes a little more sense for people if we don't feel super great about fractions is instead of thinking of this as a fraction times x, we can think of this as 3x divided by 4. And then it's the same idea as our division from A. Because we did just fine when it was division. So if I want, I can think about it as dividing by 4 here. If I think about it this way, what would I do to get rid of the 4? Multiply. So I get 3x equals 36. So we've sort of split that 3/4 up into multiply by 3, divide by 4, which is okay. But I still do have to get rid of the 3. How do I get rid of the 3? Divide. So we get x to be 12. Not too bad. Okay. Turn to the next page for me. And I want to jump down to exercise 3. Okay. Jump down to exercise 3 with me. There's a lot of words in here. We're going to solve this together. We're going to work through those steps. The words are just kind of talking about a different strategy we're going to take. So if this is distracting to you and you want to scribble through that, that is okay. But I want to take a look at this problem right here. Okay. I want you to notice this one's a little bit different than the problems that we've done so far because I have x in more than one place. So there's an x inside parentheses, then there's an x that's not inside parentheses, and then on the other side of the equal sign, there's another x that's inside parentheses again. So when I've got my x's just sort of sprinkled throughout my entire problem, before I can start talking about getting x by itself, first I need to get all the x's together, okay? So our very first step in a problem like this, what we're seeing with exercise 3, is that I need to get all the x's together first. I need to get them all on one side, all combined, and then we can talk about what we need to add or subtract or multiply or divide. So I'm going to start this problem with some distribution. I've got some x's inside parentheses and some x's not inside parentheses. I need everybody out there in the open so that I can combine them. That means I need to start by distributing. So remember, when we distribute, that means we're multiplying. So this would be 5 times x, that's 5x. And then 5 times -3 would be -15. I don't have anything to do here, so I'm just going to copy down that plus 2x equals. And then on the other side of my equal sign, I need to distribute again. So I would have 4x plus 12. So everybody's out there in the open. Now let's combine our like terms. So that means things that have x's that are on the same side already, we're going to start there. So on the left-hand side, I've got a 5x and a 2x. They're already on the same side. They're just not together. So we're going to combine them. So 5x plus 2x gives us 7x minus 15 equals. On the other side of our equation, I've got an x and a constant term. Those are not like terms. I don't want to combine them. I'm just going to recopy this, 4x plus 12. From here, I've still got x in multiple places, so I still need to combine my x's, but this time I've got to move it across that equal sign. I know for teachers you've had in the past, some of them may have told you that we always want to get x on the left-hand side. They like x to always be over here. I've seen less frequently, but I've still seen some teachers that always want x on the right-hand side. They always want x on one particular side. I like x to be positive. So I don't have a particular side that I like x to live on all the time. My favorite thing is when x, the like coefficient in front of it, is a positive number. I would rather not have x be negative if I can avoid it. So I move x based on where it will be positive, where it's going to be a positive number. Okay. Since 7 is bigger than 4, I want to keep my x on the 7x side. I want to keep it on the left. If you are always on the left person, then you can always keep it on the left. That is okay. I like to keep it where it's going to be positive. So that means I am moving this guy over here. Since it's a positive 4x, I'm going to move it by subtracting. That would be 3x minus 15 equals 12. And now this looks like the problem that we did on the first page. So what's my next step from here? Add 15. So I have 3x equals 27. Very good. One more thing to do. Divide by 3. So we get x equals 9. Very good. On this problem, I want to show you one more thing. Okay, one more thing. When we are solving later on in algebra, one of the things that I want you to get into the habit of is checking your solutions. And there are a lot of ways that we can do that. For the problem that we have here for exercise 3, we can check our solution by taking the answer that we got and plugging it back into our original equation like we did with our evaluate problems yesterday. Okay, so I got x equals 9. I'm going to check to make sure that's correct by plugging 9 back in for x in my original problem. So here's what that looks like. This would be 5 times 9 minus 3 plus 2 times 9 equals 4 times 9 plus 3. So anywhere I saw an x, I put in 9. And now I'm going to simplify. If 9 is the correct solution to my equation, that means when I simplify, the left side is going to be equal to the right side. It's going to match. So order of operations as I'm simplifying, inside parentheses first. 9 minus 3 is 6. So I've got 5 times 6 plus 2 times 9. And then on the other side, inside parentheses, I would get 12. So I've got 4 times 12 over there. I've got a whole bunch of multiplication, just going to work from left to right. 5 times 6 is 30, plus 2 times 9 is 18, equals 4 times 12 is 48. And then I've got one more operation here. On the left-hand side, 30 plus 8 is 48. Is 48 equal to 48? The left side the same as the right side? Yep, that means my solution works. Questions for me so far? Couple more we're going to take a look at together today. Let's pop down to exercise 4. We're going to take a look at A. Same idea as what we just did. I've got X in a whole bunch of different places. Last hour I said that these problems kind of remind me of, I know everybody's got AirPod things now, like stuff that doesn't have wires, but did you ever have headphones that had wires on them? And you like shoved them in your pocket and then you pulled them out and they were like a tangled mess, right? This is the tangled mess. And we are unraveling, we're poking this through here and pulling this out here. We are unraveling until we have our cords all nice and pretty again, okay? Or does anybody have that drawer at your house that's filled with chargers for things? And you try to pull one out and it's like the whole mess comes with it, right? We're untangling here. We're untangling all the cords. So my first step to untangle all the cords is to get rid of these knots here. So I'm going to get rid of them by distributing, okay? Just like we did for the last problem. So this would be 7x minus 14. And then this one's a little tricky because it's 3 that I need to distribute, but then I also need to subtract everything that I distribute. So what I'm going to do here is distribute not just 3, but negative 3, because that'll carry the subtraction through for me. So minus 3x, and then negative 3 times 3 would be minus 9, equals 5x minus 15 plus x. Now we've got to get all our x's together. I'm going to clean up each side, just like we did for our last problem. So on the left-hand side, I've got 2x terms. 7x minus 3x, they're split apart right now. I'm going to combine them. 7x minus 3x is 4x. And then my constant terms are also split apart. Those numbers are also split apart. So I've got negative 14 minus 9. Negative 14 minus 9. What would I get there? Negative 23. Very good. On the other side of my equal sign, I've got some x terms to combine here as well. 5x plus x, or 1x if that's helpful, gives us 6x minus 15. Okay. We're almost there. I've cleaned up both sides. We untangled all the knots. Okay. It's a little twisted right now still. I want to move my x terms together. Again, if you are an always on the left person, x lives on the left for you, that is a-okay. I am a x should be positive person. So what I'm going to look for is which side has the greater x. For this problem, that's over here on the right. So I'm going to move my x's to the right for this problem. Again, I like x to have a positive coefficient. So negative 23 equals, this would be 2x minus 15. I've got x's all together now, finally. Now I want to get x all by itself. I'm subtracting 15, so we will add it to both sides. Negative 23 plus 15, what do I get there? Negative 8. equals 2x. Divide both sides by 2. And what is x equal to? -4. Very good. Definitely more steps for that problem, a little bit longer, a little bit messier, but we're doing the same thing all the time. We're adding, subtracting, multiplying, dividing. There's one more I want to look at together with you. Okay, turn to the very last page for me. The very last problem on the very last page, number 4. The bottom of the last page. We have a problem here that someone has worked through to solve, but I will tell you that their answer is not correct. So I want to talk through this one with you, and we're going to find their mistake and then correct it and find the correct answer. So before we look at their work, I want to talk about what we would do if we were solving this, and then we'll compare what we say with what they did. So if you were solving this, what would you do first here? What would be your very first step? Yeah, thank you. It's just hard to hear you guys over the air sometimes. Multiply both sides by 5. Now it turns off. Okay. And that's what they did. They multiplied both sides by 5. And so they got that to go away. -2x minus -2 times x minus 3 equals 20. And now what would you guys do from here? Just distribute the -2. Would anybody divide both sides by -2 at this point? Maybe. Definitely not. You like distributing better? That's okay. Let's see what they did. They distributed. So they would have -2x. It should be +6. Here's their mistake. This should be a +6. So -2x plus 6 equals 20. Because their sign is off here, that means this is the spot where everything else is going to be incorrect. So off to the side here, let's finish this problem and find the correct answer. What's my next step from here? Good. Move the 6 to the other side by subtracting. So we have -2x equals 14. Divide both sides by -2. So we get x equals -7. Perfect. Not too bad for today? Okay. Here's what I would like you to do for homework for tonight. We skipped several problems as we worked through our examples for today. I would like you to pick 3 of the problems that we skipped and do those for homework. Your choice. Any 3 of the ones that we skipped, you can do for homework.